Kansas City, Missouri was founded in 1850, where the Kansas and Missouri rivers meet, and swiftly grew into a major commercial center. Elizabeth Rosen is a local preservationist.
Kansas City is the heart of America. It sounds really cliche, but it's a place that's easy to live, it's easy to love. There's a great community spirit here.
The city owes its success to the cattle industry.
Kansas City was historically known as a cow town. This is where the cattle came in at the end of the cattle drives coming from Texas and the grazing lands.
In the 1920s, Kansas City stockyards were handling around 2.5 million head of cattle. That's enough to make more than 2 billion burgers.
By the 1970s, agriculture gave way to architecture, and Kansas City went from cow town to city slicker with an ambitious building boom.
There was a desire to have buildings that were both unique and at the same time that were cost-effective to both build and maintain and manage. And this resulted in some really unique designs.
One building stood out more than the rest. On the site of the former Kansas City stockyards, the 17,600-seat Kemper Arena. Engineering project manager Greg Litterick explains.
Kemper Arena is very iconic and well known for its exterior skeleton and really pushing some of the boundaries of design at the time that it was put up.
This revolutionary design, covering more than 130,000 square feet, gave fans what they'd always wanted, an uninterrupted view of the action.
The uniqueness about this structure, because of the exoskeleton, is that there's no columns right now in this space. If you look around, there's nothing to get in the way of people being able to see the events that's going on.
The space-age exoskeleton is aptly known as a space frame. When originally built, it looked a little different, but its purpose was the same: to support the roof from above. 3 giant steel space frames rise 80 feet up, then extend 380 feet over the building, supporting 42 hangars connected to a lattice of joists and trusses, with high-density foam roof panels sitting above.
This system makes it so that the roof basically floats over the top of the bowl and is not reliant on the bowl for its support, nor is the bowl reliant on the support of the roof to hold itself up. They have hangers that come down and actually support the roof beams from above. And so now we don't have deep trusses inside the event center, and we don't have any columns.
The roof didn't just offer uninterrupted views. On top, it acted like a giant reservoir to catch rain from the summer storms, releasing it slowly to avoid overloading the city's sewers.
The idea was that the roof would catch rain until it reached a depth of around 2 inches. Then the water would be slowly released through 8 intentionally undersized drains. Think of it like a large bath with 8 small plug holes.
The arena opened in 1974 and was a huge success. Groundbreaking at the time, it even won an award from the American Institute of Architects for its innovative design.
It was a really unique design. We talk about thinking outside the box, and this whole building is outside the box.
The Kemper Arena was home to ice hockey, NBA basketball. Even the King Elvis Presley played here, twice.
Growing up in the area, I came to see several concerts. I came to see several rodeos. So this place personally holds a lot of very good memories for myself and my family.
On June 3, 1979, the arena was hosting the American Institute of Architects annual convention. The following day, a storm rolled into Kansas City.
A big classic Kansas City spring storm blew through the area. There's a lot of heavy rain in a very short period of time. We sometimes get tornadoes. They can cause a lot of damage.
The The storm intensified with torrential rain and gusting winds of around 70 miles an hour.
Around 6:30 in the evening, one person in the arena started to hear strange noises. As he got closer into this space, he started to hear what he called explosions and ran out.
In June 1979, at Kansas City's Kemper Arena, an employee heard strange noises during a storm. As he fled, a 200-foot section of the roof suddenly fell more than 70 feet to the arena floor. Engineer Greg Litterick knows the story.
The amount of steel and the amount of water. It was this center section, approximately 1 acre of the roof, came down.
The collapsed section was so big and the roof came down with such force that the air pressure blew some of the walls apart.
Fortunately, the arena wasn't in use at the time. If the collapse had happened just 24 hours earlier, ironically, thousands of architects would have been inside.
That was crazy. The timing, the coincidence was incredible.
Luckily, no one was hurt in the disaster, but when the dust settled, big questions were being asked. In a building designed to withstand Kansas City's stormy weather, how had this disaster happened? Professor of Engineering Norb Delat explains.
One thing you might wonder is if the roof is designed to hold water, why didn't it hold the water? That's what it was made for.
Some experts initially believed the answer could lie in a phenomenon known as ponding.
The problem is if the roof is too flexible, what happens is that as it sags, it collects more water. That causes additional sag, it collects more water, and then at some point there's so much load on it that it collapses.
Water wasn't the only problem. In Kansas City's stormy weather, the design may have underestimated the effects of the wind.
In a windstorm, which is what we had at Kemper Arena, is the water's getting pushed around all over the place, and it may find a low spot and it may find a weak spot.
The problem was storm winds were swirling the water around, and instead of draining, it started to pond unevenly around the roof, causing localized stress.
The roof weighed about 1,200 tons, and at the time of collapse is holding about 1,200 tons of water.
Further investigation found that it wasn't just the weather that was responsible for the collapse.
The heavy rain and swirling winds caused the roof to swing back and forth, highlighting a structural flaw within the hangars that had been there for 5 years. The type of bolts.
These were high-strength bolts. And when you use a high-strength material, typically you sacrifice something to get high strength. And what you sacrifice is the ductility, the ability to stretch, the ability to absorb energy.
Each of the 42 hangars was held in place by 4 high-strength bolts designed to work on rigid structures. But every time the roof moved, the lack of flexibility in the bolts caused the metal to weaken. Until, it's estimated, they lost almost 2/3 of their strength.
What happened was over the time, as the water moved around, as the wind moved the water, those bolts went through cycles of fatigue, and so they were slowly stretched and unstretched, slowly stretched and unstretched. And what happened because of this type of steel is eventually it weakens the structure and can break. But it was just the phenomenon of that slow stress repeated several thousand times that broke the bolts.
The failure of just one bolt weakened the hangar, causing the other 3 to fail. This in turn overloaded the adjacent hangars, creating a domino effect until the whole 200-foot section of the roof came crashing down.
As one broke, the next one would get overloaded and then continue to break. Sounds like an explosion, but it's really pieces of steel breaking apart.
It turned out that the bolts, although strong, simply weren't flexible enough to take the strain any longer.
Failures generally occur because you have a set of circumstances plus a trigger. The circumstances in this case were the bolts that had been weakened by fatigue over many, many years, and the trigger in this case was a particular overload of rain on this particular day.
The Kemper Arena was rebuilt and reopened on February 20th, 1980. This time with more flexible bolts, a pitched roof, and instead of 8 drains, there were now 22.
They've changed the profile of the roof so that it doesn't store as much water anymore. It effectively is now pushing all the water off of the roof and down into the drainage system.
In 1994, the stadium grew with more seating and an enlarged roof truss over a new glass atrium.
As part of that, they also expanded that central truss. Now the central truss steps back a little bit. It's a little bit larger and a little bit taller as it goes over the top.
In 2017, the stadium was transformed yet again with a $42 million makeover, this time into a sports facility for the whole community. Greg Litterick was project manager.
Personally, I was very excited to be part of this project to bring this arena that had been such a prominent role in my life growing up to now being able to revitalize the arena and make it again a place for the community to gather. I am very proud that this arena is still here and that we've given it a new lease on its life.
It's an iconic part of the community, and it's really embedded in the community's soul.
The arena came back better and crucially stronger than ever. Once again, rock legends could raise the roof without bringing it down.
And maybe this time, proud Kansas Cityans can create a few stars of their own in this very special part of town.